So 3-6 are examples. Again, a reminder of the and or thing. When we have an overlap, we have an and. When they're disjoint, we have the or. Okay, that's important. So writing a compound inequality. What compound inequality represents the phrase? Graph the solution. So here, all real numbers that are greater than -2 and less than 6. So again, we're looking greater than -2 and less than 6. It's an and, so we can actually join it together. So what that looks like, again, we'll have the n in the middle, and we want less than 6, but also, whoops, what the heck, there we go, less than 6, but also want them to still be bigger than -2. Now, we talked about in the vocab the interval notation, so that's going to look different. That's going to be that disjoint set, right? But here we're looking at the graph of it. So we have from -2 all the way to 6. I'm sorry, not disjoint. I made a mistake in what I was saying there. What I meant is, there we go, -2 to 6. Neither one's included. Okay, that's what I was trying to spit out. But anyway, so this is an interval notation piece. It doesn't ask you for that in here, but I thought it might be kind of fun to include it since we had that discussion earlier. With B, all real numbers that are less than 0 or, notice, or greater than or equal to 5. Again, notice it's a disjoint set. There's no overlap, so we have that or piece going on. So less than 0, greater than or equal to 5, so filled in dot there. And this is where we would write that if we did interval notation, we have negative, and that's not an infinity sign. Whoops. Forget that. Negative infinity, I've tried to write an 8. All the way up to 0, 0 not included, and you would write or, and then you'd put 5 is included all the way to infinity. Okay? So to kind of practice that interval notation. So there we have it. And let's take a look at the got it's here on the next slide. Never mind, we'll just do it right here. In parts A and B below, write a compound inequality that represents each phrase. Graph the solution. So all real numbers that are greater than or equal to -4 and less than 6. So again, you're going to write x is, let's see here, greater than or equal to -4, but x is less than 6. So this one you could use the mirror trick, right? So if you want to be able to write it the other way, x less than or equal to -4. So now we have it where the variable's in the middle for both. So you can say -4 less than or equal to x less than 6. And then the graph, obviously, again, open at 6, heading to the left, filled in at -4, heading to the right, looking for the overlap there, the or. B, it says all real numbers that are less than or equal to 2.5 or greater than 6. We know, obviously, that that's not going to have an overlap in it, right? So less than or equal to 2.5, greater than 6 leaves that gap in the middle here. So again, we're going to have to write it as an or statement for a compound inequality. So x less than or equal to 2.5, greater than 6. And the graph, again, filled in at 2.5 because of the equals part, heading to the left forever. And open at the right, or open at 6 rather, heading to the right forever. C then, what is the difference between x is between 5 and 7 and x is between -5 and 7 inclusive? The inclusive means I include the 7. Okay, and the 5. So inclusive means that the dots are filled in, if you will, at -5 and 7. When I don't say that, it means that the dots are not filled in. It's not included. Alrighty, so solving a compound inequality involving and. So it's important to remember that the and, right, is that overlap part here, right here. So you can solve an and, by the way, as a single unit. You can also break it up, right, into this half. So notice this half, and this half, this half. I like to solve them together. Only with ands, though, can you solve them together. Move this up just a little bit, and we'll do that. So you're going to have -3 less than or equal to m minus 4 less than -1. Again, only with the ands. And you got to watch that whole division with negative things, multiplication division with negatives. I don't have that in this, though. So I can say +4, +4, +4 on all three sides. -3 plus 4 is 1, less than or equal to m, because this cancels out, less than 3. So obviously, it's between 1 and 3. The 1 is a filled-in dot on my graph. The 3 is an open dot, and it's everything in between there. So for your got it, you've got negative 2 less than 3y minus 4 less than 14. So obviously you're going to solve it pretty much like a like a two-step equation, only I have 3 parts to solve. So add that 4, add that 4, add that 4. So we're going to have 2 less than 3y less than 18. Again, the 3 is positive, so no need to flip anything. Divide the 3 off. So we're going to have 2/3 less than y less than 6. And again, only with an and can you solve it this way. If there's an or, you have to solve them as separate pieces. Anyway, so what's that look like? Well, we're going to have, oops, grab this one right here instead. There we go. We're going to have an open dot at 2/3, an open dot at 6, and fill in the middle. These kind of problems are always fun, I think. Maybe you don't agree. I don't know. I guess we'll find out. You'll see these on my quiz and my test, too. So anyway, to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. Okay? You scored 86, 85, 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? Now, forgetting the ends here, so ignore those for the second. To get an average, you add together and divide by the number of numbers, right? So you had 86, 85, and 80. The unknown score x, so that's where a let statement would be nice, right? Let x equal the unknown score. And divide that by 4. Again, the ones you know, the one you don't know, divided by 4. Now that must be between 84 and 86 once you're done with the average. That's how I got the middle part. That's the averaging piece. And again, it's inclusive, so you have the equals part. Okay, let me say that again. The 3 scores you know, the one you don't know yet, divided by 4 because there's 1, 2, 3, 4 scores. That's the average. That has to fall between 84 and 86 inclusive. That's the equals part. So add these 3 up, right? Get your 251. Carry along your x divided by 4. Now obviously order of operations, you can't subtract the 251 off because it's grouped in the top. So you do have to divide the 4 off first, or multiply the 4 off, I'm sorry. Multiply the 4 off first. So we get 336 is less than or equal to 251 plus x is less than or equal to 344. Then subtract off your 251. So we get your last score must be between 85 and 93 in order to get that B average that you want, 84 to 86. Now if you earn more, that's fine, right? It'd bring it above, so that's a good thing. Alright, so continuing. Suppose you scored 78, 78, 79 in the first 3 tests. Is it possible to get that B in the course? And again, you must have between 84 and 86. So we're going to model it on this one here, right? So remember your B is 84 to 86. I'm going to put that in interval notation there. And let's slide this up out of the way then. So we have my 78, right? So I have a 78 plus my 78 plus my 79 plus my unknown x divided by 4. That's how you get the average. Has to be between 84 and 86. That's going to give us 235 plus our, that's not a 5. I saw the 4 in front of my face. 235 plus our x divided by 4, less than or equal to 84. Right, let's equal to 86. There we go. So it's between 84 and 86 again. So just like before, we're going to multiply off that 4 first off, right? I'm going to erase so I have a little bit of room to write here. We're going to multiply off that 4, multiply off the 4, multiply off the 4. So we get 336, just like before, right? 235 plus x less than or equal to. And then we subtract off our 235. So minus 235, minus 235, minus 235. It's kind of fun to work on 3 fronts, right? So we end up finding out that unless your teacher gives some serious bonus, which I don't, no, you can't get there. You done messed up already. So anyway, between 101 and 109 is what you required. There you go. Okay, so as promised, solving with OR means you do have to keep it split in half because it's, technically the disjoint sets, right? Taking a look here. Solution of a compound inequality involving OR is any number that makes either one true. Okay, so one or the other. It obviously can't be an and because there's no overlap. Hope that makes sense to you. Again, it can't be an and. It can't be in both. To solve a compound inequality involving OR, you must solve separately the two inequalities that form the compound inequality. So, again, if we say, what are the solutions of 3t plus 2 less than 7, or negative 4t plus 5 less than 1? So, solve this one. Again, subtract the 2, divide the 3. Please pay attention to if you're multiplying or dividing with a negative. Right? Obviously, this is a positive 3, so I don't have to flip anything. And then over here, subtract that 5, divide off the negative 4. Notice, again, flipping the inequality when I personally multiply or divide by that negative. So I get t is less than negative 3 or t is greater than 1. And again, so greater than 1, no filled in dot, less than negative 3, no filled in dot. So here we're going to solve two different ones. Negative 2y plus 7 less than 1, or 4y plus 3 less than or equal to negative 5. And so obviously subtract the 7, subtract the 7. Negative 2y less than negative 6. Now again, going to be dividing by a negative, so I flip this thing immediately, right? So y is greater than positive 3. And over here, subtract the 3, subtract the 3. 4y less than or equal to negative 8. Divide the 4. Y less than or equal to negative 2. Now again, the graph of that, taking a look here, we're going to have y is greater than 3. So that's open at 3, heading to the right. And y is less than or equal to negative 2, so filled in at negative 2, heading to the left. There's our OR. Just a reminder with interval notation what that looks like. So again, we've got so less than gets the parentheses on the ends, right? Less than or equal to, the equals part, gets the brackets on the end. Positive and negative infinity always get parentheses. So again, x is greater than 2, greater or equal to 2, filled in dot at 2, heading to the right. Bracket, try to spit that out, 2, and again all the way to infinity and beyond, gets parentheses. So make sure we pay attention to how we use those for interval notation. So here, using interval notation, what is the graph of negative 4 to 6? So again, negative 4 is included. That is the filled in dot. 6, not included. So it gets an open circle. And how do you write this as an inequality? This is the compound inequality piece. So obviously, you have to be greater than negative 4, right? So you can start out like this. You can start out x is greater than or equal to negative 4. And, right, it has to be an and because it's that piece in the middle there. And x is less than 6. And again, it's an and, so you can create that overlap. So obviously, negative 4, oops. There we go, let's try that again. Negative 4 less than or equal to x less than 6. So that's how we get the compound inequality piece. And again, obviously, the graph of that. Continuing then. There we go. Part B, what is the graph of, again, we have an OR here. X is less than negative 1 or x is greater than 2. And how do we write that in interval notation? So obviously the graph says, now here's the great thing. Once you graph it, the interval notation part kind of pops out of it. You can see here, negative 1's included, head to the left to negative infinity. 2 is not included, heading to the right to positive infinity. So we can obviously see parentheses for the negative infinity, bracket for the negative 1 because it's the filled in dot, parentheses for the 2 because it's the open dot, positive infinity because we're heading to the right forever with parentheses. I think it's easier to graph it than write interval notation. Alrighty, jumping right to this one. What is the graph? So from negative 2 to 7, notice the 7 is filled in dot. Negative 2 is not. It's everything in between. How do you write this as an inequality? Obviously, it goes from negative 2, not included, just so no equals, all the way to 7, included. What is the graph of y is greater than 7? So again, 7, notice, no equal sign, so open dot. Positive infinity going on forever. So again, parentheses for the 7, positive infinity, parentheses for interval notation.